Good morning everyone. Today we are going to continue with the chapter Metals and Non-Metals. So last time we did the chemical properties of metals. If we talk about non-metals, about the chemical properties of non-metals, like we did the chemical properties of metals. First property was its reaction with oxygen. If we talk about non-metals, they react with oxygen to form acidic oxides. For example, we can take like carbon. Carbon is a non-metal. It will react with oxygen to form carbon dioxide, which is an acidic oxide. Or we talk about sulfur. Sulfur plus oxygen, that will form sulfur dioxide, and we can test this with the litmus paper. Right? So that is, if we dip a blue litmus paper in it and the moist gas, it will turn into red color. Right? Then second property, that is reaction with water. So these non-metals, they do not react with water at all. Right? Neither do they react with steam. The cold water, hot water or steam, they do not react with water at all. Then we did the property of reaction of metals with dilute acids. So non-metals do not react with dilute acids too. They do not react. And then we did the reaction of metals with the other salts. So here if we talk about non-metals, more reactive non-metals can displace the less reactive. Like if we talk about sodium bromide, if it reacts with chlorine, right, then it can form NaCl plus bromine. So now next, these are the properties of non-metals. Then today we are mainly going to discuss this topic that you can see here. How do metals and non-metals react? Right? What happens when they react with each other? Now we know we have done the noble gases. In class 9 we have read about inert gases like helium, right? Helium or neon, argon, krypton, xenon and all, and we know that they are also known as inert gases. Why they are known as inert gases or noble gases? Because they have a complete completely filled valence shell, right? They have a completely filled valence shell, and that is why they are very, very stable. They do not react with any other element, whether metal or non-metal, right? So what the other metals or what the other elements do now, when they react, they also try to gain stability by attaining an octet. That is how they react together, metals and non-metals, by trying to gain or lose electrons so as to attain an octet, or so as to attain stability or an inert gas configuration, right? Like we take the example of sodium metal, right? What happens when it reacts with chlorine? Now we know sodium, the atomic number is 11. So its electronic configuration will be 2, 8, 1. And chlorine, its atomic number is 17. So its electronic configuration is 2, 8, 7. Now if sodium gives away this one electron, it will have the electronic configuration 2, 8. That means the outermost shell is completely filled. And if here chlorine takes one electron, it will have the electronic configuration 288. So here also the outermost shell becomes completely filled. Right? So here Na and Cl both, they try to gain an octet by either losing the electron or gaining the electron. So we can show this by either we show it by a dot or a cross, right? Anything you can put. And we always show this by writing only the electron, the number of electrons present in the outermost shell. So Na, it has got 1 electron in the outermost shell, so we show it with 1 dot. Plus chlorine. Chlorine has 7 electrons in the outermost shell. So we put 7 dots. You can either put dots or a cross. Right? 7 electrons in the outermost shell. So here what will the sodium do? It will give 1 electron. And this transfer of electrons is known as the compounds which are formed after the transfer of electrons, they are known as ionic compounds. Ionic compounds. Or they are also known as electrovalent compounds. Electrovalent compounds. Right? So what are ionic compounds? The compounds which are formed by the transfer of electrons. So either they are called as ionic compounds or they are called as electrovalent compounds. So, and what happens here? When this will give away 1 electron, right? From here it will transfer 1 electron here. This will become positively charged. And because it is taking 1 electron, this will become negatively charged. And you know that positive and negative ions, they always attract each other. Right? And when they attract each other, they will form a compound known as NaCl. And during this transfer of electrons, or you can say when the positive and the negative electrons, they come closer to each other, they have a bonding between them, right? A bond is formed, which is known as the electrostatic bond. Right? Or they have an electrostatic force of attraction. Electrostatic force of attraction between them. This bond or the force of attraction is known as electrostatic bond or electrostatic force of attraction. So here when this sodium, it will pass 1 electron, this will become 2,8 and this will become 2,8,8 and it will form a compound that is Na with 1 positive charge and chlorine with 1 negative charge. Right? Here chlorine, now it will have 8 electrons. So this becomes 2,8. Here we can write 2,8,1 and 2,8,7 first. And here you can write 2,8 and 2,8,8. This is how an ionic compound is formed, or this is how the transfer of electrons take place. Right? We can take more example like and this bond which is formed between them, This is a very strong bond because it is formed by the two oppositely charged ions. Right? We take the example of MgCl2. Right? If we take this example, now here Mg, you know, its atomic number is 12. So what will be the electronic configuration? 282. And chlorine, again it has the atomic number 17. So this will be 287. Now it has got 2 electrons in the outermost shell. This has got 7. That means to attain stability, it can give us the magnesium element. It can give away 2 electrons. But chlorine needs only 1 electron. Right? So what will happen here? We can write like this. Magnesium, it will give away 2 electrons. Right? And chlorine, here it will then combine with 2 atoms of chlorine. It cannot combine with one atom only because here it can give 2 electrons. Chlorine can take only 1. So it will combine with 2 chlorine atoms. 2 chlorine atoms will take the electrons and become negatively charged. This will become positively charged. So how this transfer of electrons will take place? Let us show that. So magnesium, it has got 2 electrons in the outermost orbit. So we will make 2 dots here. And chlorine, it has got 7 electrons. So we will make 7 dots. But here we will show 2 chlorine atoms. So it will give 1 electron to this chlorine atom and 1 electron to the other chlorine atom, and this will have a charge of 2 positive ions, and chlorine 2, 3, 4, 5, 6, 7 and 8. Right? It will gain a negative charge. We will write 2 here to show that there are 2 chlorine atoms. Right? So this is how the transfer of electron can be shown here. We will take one more example. Let's take one more example. We can take up magnesium oxide now. Right? Magnesium oxide. Now again, magnesium, it is 282 plus oxygen. Now oxygen, it will have how many electrons? The atomic number is 8. So it will have 2, 6. That means here it can give away 2 electrons. Oxygen, it can take 2 electrons. Very simple. And so here what will happen? Magnesium will become 2 positively charged and oxygen is 2 negatively charged. Because they are having the same number of charges, we can write it as MgO. We can show the transfer of electrons here. Magnesium, it has got 2 electrons in the outermost orbit. It will react with oxygen having 6 electrons in the outermost orbit. Right? So here it will take 1 electron, both the electrons from magnesium, and magnesium will become 2 positively charged and oxygen will become 2 negatively charged. So we can write it as MgO. Clear to everyone? So this is how the transfer of electrons take place between metals and non-metals. There is another type of bond also which is known as covalent bond, that you will read in the chapter of carbon and its compound. This covalent bond, now electrovalent bond is always between a metal and a non-metal. Transfer of electrons will take place always between metal and non-metal. While covalent bond, it is formed by sharing of electrons between non-metals only. Between two non-metals only. Always it takes place between non-metals. While electrovalent bond, it takes place between a metal and a non-metal. Right? Now, these ionic compounds, we will learn about some general properties of these electrovalent or ionic compounds. These are very important. You get some reasoning questions also in exams on this. So the properties of ionic compounds. First is its physical nature, how it appears. Now when you are learning its properties of ionic compounds, one thing you remember this salt, NaCl. When you remember this, because this is the common salt, namak jo aap hamesha use karte hain apne ghar mein bhi, and you know how it looks and all. So you can relate all the properties to this. So remember this salt, this is the best example for electrovalent compounds. So physical nature, now how does it looks? A solid or a liquid or a gas? You all know NaCl NaCl is a solid. Not looks like a solid, but it is a solid. So you can write the physical nature, it is solid and hard, rigid. Right? And why it is solid and hard? Because of the strong force of attraction between the ions. Strong force of attraction between the ions. Right? This is how you get the questions also in exam. Why it is strong and hard? This is the reasoning question. Because of the strong force of attraction between the ions. Then next we can take another property of this, that is high melting and boiling point. Right? Melting point and boiling point, you can give the heading. Now these ionic compounds, their melting point and boiling point is high. Now why it is high? That also because of the considerable amount of energy which is required to break the force of attraction. They require a considerable amount of energy to break the bond. Right? When we heat them, they require a considerable amount of energy. That is why their melting point and boiling point is high. Third point is solubility. You all know this NaCl, it is soluble in water. So, it is all the ionic compounds, they are soluble in water and insoluble in organic compounds like petrol, diesel or kerosene. You can write petrol, kerosene, etc. Right? If you remember NaCl, you will remember that this is soluble in water. Fourth point, that is its conduction of electricity. Now, in solid form, can NaCl conduct electricity? No, it does not conduct electricity when in solid form, right? Do not conduct electricity in solid form. But in molten state or in solution, it conducts electricity. This question comes in boards also, in board exam also, that why it cannot conduct electricity in the solid form and why it conducts electricity in the molten state or solution form. Now what happens actually in solution form, this NaCl, it will break into ions, and you know, to conduct electricity charges are required. It has to be in the ionic form, right? So in the solid form it is rigid, there are no free charges, so no electricity will be conducted. But when it is in the molten state or in the solution form, what will happen? It will break down into ions. So the force of attraction will be less, right? It will separate out in solution form. It will break down into positive ions of sodium and negative ions of chlorine. That is why, because the ions are there, the charges are there. In the ionic form, charges are present. So it will be possible to conduct electricity, right? So these are the properties of ionic compounds. Learn them nicely, because questions are based on this. Reasoning questions can be asked based on this. And now after this, you have in your books, you have extraction of metals and corrosion. That portion has been deleted for this year, right? You have the syllabus only till here for this year. So you don't have to do that portion. So with this, we finish this chapter, right? So I hope you have enjoyed this chapter. This is a very nice chapter, of course, and learn it nicely now. If you have any queries, you can put them in the comment box. For transfer of electrons, you can try aluminium chloride, potassium chloride, sodium oxide. Try the transfer of electrons in this. If you are having any problem, then you can ask. Thank you.